All right, let's go.
Number 12. The moon has no air, but it has something. This one seems obvious. The moon has no atmosphere. You already knew that. But here is what most people do not know. It has something, just barely. It is called an exosphere, an extremely thin envelope of particles clinging to the surface. Sodium, potassium, argon, helium, water molecules, but so thin that individual atoms almost never collide with each other. It is not an atmosphere in any meaningful sense, more like a ghost of one. NASA's LADEE mission confirmed this in 2013. It orbited the moon for 6 months, measuring the composition of this surface-bound exosphere precisely. Where does it come from? 3 sources. Solar wind constantly deposits particles onto the surface. Micrometeorite impacts kick material up off the ground, and radioactive decay inside the moon releases gases like argon and helium that seep out through the surface. It is also constantly being lost. Solar radiation strips it away, and it is constantly being replenished. The exosphere is not stable. It cycles, day and night, season to season. Simple, but important. It tells us about the flow of material across the inner solar system.
Number 11. The moon is moving away from Earth every single year. Apollo astronauts left something on the surface that scientists still use today. Retroreflectors, mirrors placed at 6 different locations on the lunar surface between 1969 and 1973. From Earth, observatories fire laser pulses at these mirrors and measure the time it takes for the light to return, down to the picosecond. The measurement is accurate to within a few millimeters. What those measurements show is direct. The moon is moving away from Earth at a rate of 3.8 centimeters per year, every single year, slowly but continuously. The reason is tidal friction. Earth's oceans bulge toward the moon from gravitational pull, but Earth rotates faster than the moon orbits, so the tidal bulge is always slightly ahead of the moon. That offset pulls the moon slightly forward in its orbit, giving it extra energy, pushing it outward. Run this backward in time and the implications are significant. The moon was once dramatically closer. Early Earth experienced tides tens of meters tall. Days lasted only a few hours. The lunar tidal breaking is actually what slowed Earth's rotation down to the 24-hour day we have now.
Number 10. The moon's surface will kill you in ways you do not expect. The moon looks peaceful from Earth. Smooth gray plains, quiet craters, nothing moving. Up close, it is something else entirely. The surface is covered in regolith, pulverized rock and mineral dust produced by 4.5 billion years of meteorite bombardment. It looks like fine powder. It is not like sand on a beach. Every grain is razor sharp. Micrometeorites that hit the airless surface do not get worn down by water or wind. They shatter into jagged fragments with edges at the microscopic level. These fragments cling to everything electrostatically. On the sunlit side, the surface charges positively. On the dark side, negatively. The dust actively jumps and clings. Apollo astronauts felt this immediately. Regolith clung to their suits, scratched their helmet visors after just hours outside, got into every joint and seal of their equipment. Apollo 17 astronaut Harrison Schmitt developed what he described as lunar hay fever from the dust entering his suit. Sneezing, watery eyes, congestion that lasted hours. Extended exposure to this dust would cause serious lung damage. The particles are so small, they penetrate deep into lung tissue and do not come out. One of the most significant unsolved engineering challenges for future lunar bases is how to deal with dust that is literally trying to get into everything.
Number 9. The moon was violently volcanic and stopped. Look at the moon on a clear night. You can see large dark patches. Ancient people called them Maria, Latin for seas. They thought they were actual oceans. They are not oceans. They are dried lava fields. Apollo samples confirmed this. The dark plains of the moon are basaltic rock, solidified lava flows, produced by massive volcanic eruptions between 3 and 4 billion years ago.
During this period, the lunar interior was hot enough to drive enormous volumes of molten rock to the surface. Floods of lava poured into the low-lying impact basins and froze solid. That is what we see today. The moon eventually cooled, the volcanism slowed, then stopped. For decades, scientists assumed the moon had been completely geologically dead for over 1 billion years. Some patches on the near side appear to be far younger, possibly as recent as 50 million years ago, which is extremely young in geological terms. Volcanoes may have been active on the moon when our early primate ancestors were just beginning to evolve. Whether these patches represent true young volcanic activity or just a different type of lava that looks younger than it is remains an active debate. But the moon's volcanic history is not as simple as it once seemed. Number 8. The moon is shrinking, and it is causing earthquakes right now. The moon is cooling, has been cooling since it formed 4.5 billion years ago. As its interior cools, it contracts slowly, steadily. That contraction has to go somewhere. It goes into the crust. As the interior shrinks, the crust gets compressed, pushed together. It buckles, forms cliffs called lobate scarps, stair-step-shaped ridges where one section of crust is pushed up and over another along a fault line. LRO has found thousands of these scarps across the entire lunar surface. Many of them look geologically fresh, not billions of years old, potentially active. The numbers are striking. The moon has lost roughly 50 meters in total diameter over its history. The scarps extend for kilometers, rise up to 100 meters high, and they are found everywhere, including near the lunar South Pole, directly in the planned landing zones for future Artemis missions. A 2026 study mapped over 2,600 small tectonic ridges across the lunar marea. The average age of these ridges, 124 million years. Young. Apollo seismometers recorded thousands of moonquakes between 1969 and 1977. Some reached magnitude 5. But unlike earthquakes lasting seconds, moonquakes last for hours. The moon has no water inside it to absorb seismic energy. Vibrations just keep bouncing. Building structures on a surface that shakes for hours from a magnitude 5 quake is a serious engineering problem. The moon is not dead. It is still moving. Number 7. Water ice exists on the moon in craters that have never seen sunlight. For decades, scientists suspected but could not confirm it. In 2009, they ended the debate with extreme measures. NASA deliberately crashed a spacecraft into the moon. LCROSS, the Lunar Crater Observation and Sensing Satellite, guided a spent rocket booster into Cabeus Crater near the lunar South Pole. The booster weighed 2,300 kilograms. It hit at 2,800 meters per second. The impact released energy equivalent to roughly 2 tons of TNT. The LCROSS shepherding spacecraft flew through the debris plume 6 minutes later before itself impacting. Its instruments detected water vapor, water ice, hydrogen gas, ammonia, methane, silver, mercury, confirmed directly from the plume chemistry. India's Chandrayaan-1 had already mapped the surface from orbit using its moon mineralogy mapper and found water molecules spread across the surface. Lunar Prospector had detected hydrogen concentrations at the poles years earlier. The mini-SAR instrument on Chandrayaan-1 identified more than 40 permanently shadowed craters near the North Pole alone, containing an estimated 600 million metric tons of water ice. These craters have never seen sunlight, not in billions of years. Their interiors are among the coldest places in the entire solar system. The LRO Diviner instrument measured temperatures inside Hermit Crater at the North Pole at around minus 247 degrees Celsius, the coldest measured spot anywhere in the solar system, including the outer planets. The water inside may be ancient, possibly delivered by comets during the late heavy bombardment over 3 billion years ago, sitting there, frozen, ever since. Number 6. The far side of the moon is a completely different world. The moon is tidally locked. The seam face always points toward Earth. We never see the other side from the ground. When spacecraft finally photographed the far side, the images were immediately strange. Not what anyone expected.
The near side is covered in dark, flat volcanic plains, the mare. The far side is almost entirely different, cratered, ancient, pale, almost completely lacking in volcanic plains. The two hemispheres of the same moon look like they belong to two entirely different objects. The asymmetry is one of the longest-standing mysteries in lunar science. In 2019, China's Chang'e 6 became the first spacecraft in history to land on the far side. It touched down in the von Karman crater inside the South Pole Aitken Basin, the largest impact crater in the solar system, 2,500 kilometers wide, 8 kilometers deep, formed by a collision 4.25 billion years ago. In 2024, Chang'e 6 went further. It became the first mission to return samples from the far side, 1,935 grams of material collected from the floor of this ancient basin. Studies published in Nature in 2025 analyzed these samples and found the far side's volcanic history was completely different from the near side. The mantle composition underneath the far side is distinct. The timing of its volcanic activity was different. Its ancient magnetic field was different. The most widely accepted theory proposes a second smaller moon, that early in solar system history, Earth may have had two moons. The smaller one eventually collided with the far side in a slow-motion impact, piling extra crust onto the far side, making it thicker, harder for lava to punch through, explaining why the volcanic plains never formed there. The Chang'e 6 samples have not confirmed this theory, but they have confirmed the asymmetry goes much deeper than the surface.
Number 5. The moon has enormous underground tunnels, big enough to build a city inside. The moon was once heavily volcanic. Lava flows moved across the surface in enormous rivers. When the outer surface of a lava flow cools and hardens, the molten rock inside can keep moving. Eventually, it drains out completely, leaving behind a hollow tube, a lava tube. These structures exist on Earth. In Hawaii and the Canary Islands, you can walk through lava tubes hundreds of meters long. On the moon, the same process happened, at a much larger scale. The moon's lower gravity means lava tubes there could be hundreds of times larger than on Earth. JAXA's Selene mission and subsequent data from LRO and Chandrayaan-1 revealed large pits on the lunar surface, holes where the roof of a lava tube has partially collapsed. Looking into these pits from orbit, they appear to open into much larger underground spaces below. One pit near the Sea of Tranquility is approximately 100 meters wide at the opening. The void below is estimated to extend potentially hundreds of meters in all directions, long enough to fit an entire city block underground. These tubes offer something extremely valuable for future human exploration: natural shielding. The moon's surface is bombarded by solar radiation, cosmic rays, and micrometeorites continuously. Human beings cannot live on the surface long-term without massive shielding. Inside a lava tube, temperatures are stable, around -20 degrees Celsius, constant. The rock overhead provides natural radiation protection. No need to build thick walls from scratch. The moon has already built them. ISRO is planning a dedicated lunar lava tube mission specifically to explore these structures. ESA has included lunar lava tubes in its long-term habitation planning. Number 4. The moon is made of Earth. Every Apollo mission brought rocks home, 372 kilograms total, spread across 6 landings. Scientists have been studying these samples for over 50 years. One finding stood above all others. The moon's isotopic composition is nearly identical to Earth's mantle. Not similar, nearly identical. Isotopes are versions of the same element with different numbers of neutrons. Different solar system bodies, Mars, asteroids, meteorites, all have distinct isotopic signatures. They formed in different regions of the solar nebula. They absorbed different proportions of different isotopes based on where they assembled. The moon has essentially the same isotopic fingerprint as Earth for oxygen, for titanium, for chromium. This is not expected if the moon formed somewhere else or was captured by Earth's gravity. It directly confirmed the giant impact hypothesis, the leading theory for the moon's formation. Approximately 4.5 billion years ago, a planet roughly the size of Mars, called Theia, collided with the early Earth. The impact was not head-on, a glancing blow. Enormous quantities of material from both Earth's mantle and Theia's mantle were blasted into orbit. This material coalesced over thousands of years into the Moon. Because so much of the Moon's material came from Earth's mantle, the isotopic signatures match. The Moon is largely made of proto-Earth, a piece of our own planet knocked loose by the most violent event in Earth's history and frozen into orbit. New isotopic studies from 2023 and 2024 pushed the formation timeline even tighter. The Moon may have assembled from that impact debris in as little as a few thousand years, which in geological terms is essentially instantaneous. Number 3. The Moon once had a magnetic field, and we do not know why it died. Earth has a global magnetic field, generated by its liquid outer core spinning around its solid inner core, a planetary dynamo. It protects us from solar wind. It keeps our atmosphere from being stripped away. The Moon has no global magnetic field today, no active dynamo, nothing. But lunar surface rocks are magnetized. Apollo samples brought home showed clear remnant magnetization. The rocks were magnetized when they formed, which means the Moon once had a global magnetic field of its own, strong enough to magnetize minerals as they cooled from the molten state billions of years ago. Selene and Chandrayaan-1 mapped magnetic anomalies across the lunar surface from orbit, regions where the crust retains significant magnetization. Some of these regions are on the exact opposite side of the Moon from major impact basins, suggesting the impacts were strong enough to send shockwaves through the entire Moon and concentrate magnetized material on the far side. The Chang'e 6 samples analyzed in 2025 provided the first direct magnetic measurements from the far side. They confirmed the far side had its own distinct ancient magnetic history, different in timing and intensity from the near side. How did the Moon lose its magnetic field? The leading answer is simple. It cooled. The liquid metallic core solidified. The dynamo stopped. But the exact timeline and the mechanism are still being worked out. A world that once had a magnetic field capable of protecting it now has nothing. If the Moon had kept that field, the story of early life in the inner solar system might have been completely different. Number 2. The Moon's south pole may be the most valuable place in the solar system. In August 2023, India made history. Chandrayaan-3 touched down near the lunar south pole, the first spacecraft ever to land there. The Pragyan rover rolled out and began analyzing the surface. What it found confirmed what orbital data had suggested: sulfur, oxygen, iron, calcium, titanium, aluminum, silicon, all on the surface near the South Pole, and water ice in enormous quantities locked into permanently shadowed craters, hundreds of millions of tons of it. Here is why this matters more than almost anything else on this list. Water ice is not just water. In space, it is rocket fuel. Water can be electrolyzed using solar power into hydrogen and oxygen. Hydrogen and oxygen are what liquid-fueled rockets burn. A supply of water ice on the Moon means the Moon can be a refueling depot. Spacecraft launched from Earth do not need to carry all their fuel for the entire journey. They can tank up at the Moon, making missions to Mars, to the asteroid belt, to the outer solar system dramatically cheaper and more achievable. The South Pole also has something the rest of the Moon does not: near-permanent sunlight. Certain crater rims at the South Pole receive sunlight for up to 89% of the lunar year, called peaks of eternal light. Solar panels placed there could generate power almost continuously. A permanent base there could run on solar energy almost indefinitely. Water for life support, water for fuel, near-permanent solar power. And this is why the South Pole is the target of every major space program on Earth right now. NASA's Artemis, China's lunar program, ESA, India, Japan, they are all headed to the same spot. Number 1. The Moon settled the question of where the Earth came from. This is the deepest discovery of all, and it came from a pile of rocks in a laboratory.
When Apollo samples arrived on Earth, scientists expected the moon to be made of something generic, primitive solar system material, carbonaceous chondrite-type material, common in the early solar system. Instead, they found Earth's own mantle, the same isotopes, the same ratios, the same fingerprint. This single discovery confirmed something that transformed our understanding of how planets form, not just the moon, all planets. The early solar system was violent, chaotic. Planet-sized objects were forming, colliding, merging, and being destroyed continuously. Earth itself was not a quiet, steady accumulation of drifting debris. It was assembled through catastrophic impacts, including one that almost destroyed it entirely. Thea's collision with Proto-Earth was not a minor event. It was an impact so violent it melted the entire surface of the planet, vaporized an ocean of rock, sent the equivalent of a Mars-sized planet's worth of material into orbit. The moon is the debris from that event. It is the proof that planet formation is not a gentle process. It is evidence locked in orbit for anyone to see who knows what they are looking at. Every time you look at the moon, you are seeing the aftermath of the most violent event in Earth's history, a collision that almost did not leave Earth intact enough to become the planet life eventually evolved on. That is what is sitting in the sky. Not just a light, not just a tide maker, a 4.5 billion-year-old scar.
12 discoveries. From the ghost of an atmosphere too thin for individual atoms to collide, to mirrors on the surface bouncing lasers back to Earth proving the moon drifts further away every year, from razor-sharp dust that scratches visors and invades lungs, to ancient lava fields covering a third of the visible surface. From a shrinking moon generating moonquakes that last for hours, to craters colder than the surface of Pluto holding hundreds of millions of tons of ancient ice. From a far side so different it looks like another world entirely, to underground tunnels wide enough to shelter entire cities. From rocks made of Earth's own mantle proving a catastrophic origin, to a lost magnetic field that died when the core froze. From the most resource-rich piece of real estate in the solar system sitting at the South Pole, to the single finding that proved how planets are actually built. We have 382 kilograms of moon rock. We have sent over 100 missions, and the moon keeps producing answers that raise new questions. Subscribe to Cosmic Hives. See you in the next one.